add on.
No, I won't say it.
If you want to point it out at the end, and then I will pick up from that and then start talking. Wait, yeah.
It's Morgan Land.
Actually, it could be, Halloween.
Like, that's my overall goal. Like, I want to
That's a good point. I didn't think of that. Look at how steady that is.
like, I want like to say stop. Like, these guns through here. Yeah.
Apparently,
It's hard,
they
yeah.
said there were
So you're not gonna ask if it's like by the pass.
at the end of the thing, and they don't know it's about to start, and then quickly consolidated.
Okay, yeah, so we can, so it's different. Whoopsie.
John, we're ready to go.
Oh, okay.
Live stream's up.
Okay. Oh, sorry.
Yeah.
Okay, welcome to, let me turn this off.
I thought it was great. Yeah, like, I really have not found this. Like, I have, I'm like my roommate.
Okay, thanks for coming to our weather discussion. This will be the last one until next Friday. I caught you, didn't I? I mean, sometimes I get to say that the last one till September or something. No,
Last
just
daylight
next one.
saving time will
Yeah, well, that's actually a good point.
Yeah.
We'll be starting an hour earlier, sometime.
be 18
Later.
BC instead of 17.
Yeah, that's right. So, okay, a big story this week, of course, perhaps the biggest story of the entire season is now Hurricane Melissa and the devastation that it wrought over the Caribbean, particularly Jamaica and eastern Cuba. So I think you've been watching this as you've been settling in. This is 1 minute data in the meso area, so Pete apologized, he doesn't have to, but he did anyway, that it jumps every time it gets to 18Z. But I was struck by how incredibly steady state this thing was for such a long period of time. This is only intercepting the last several, tens of hours before it actually struck the poor people of West Jamaica. And just amazing. At this 1 minute data, you can see all kinds of different things. First, there's no doubt there's gravity waves emanating from the center of that thing. It looks like something out of Doctor Who from the 70s or something. And I think the reason must be that you're just pounding on the tropopause. Even though it's at 15 kilometers or maybe even 17, just consistent pounding on it by eye wall convection sets these waves off, and they're constant. The adjustment to them, I don't know if there's that much weather associated with it, but I admit ignorance, I don't know. The constraints on what they do in the lower latitudes is a little bit less than it is in the higher latitudes, I do know that. But nonetheless, just an amazing event. That's one thing I noticed when I watched these animations. Another thing is, you can see the anticyclonic rotation at the far field of the tropical cyclone, which of course has to be the case. The air here is exceptionally warm through the whole column compared to what it is far on the periphery. Consequence is there's an anticyclone at some level in the upper troposphere. And so you can't miss that. So that's really interesting. And then the brightness temperatures here in the black are on the order of 200 Kelvin. And then when you get to the purple, you're at about 180. So we're talking about probably cold point tropopause-like temperatures somewhere at the top of this thing. And just an amazing event. You'll see when we look at the current ops even now, and this is don't forget, this is from the 28th of October, so 3 days later, this thing still has integrity. This vortex is not easy to dispel. It's going to gradually lose it over the weekend, but I think there probably will be some vortical structure of this thing detectable at some level in the lower troposphere all the way to the mouth of the Labrador Sea. I wouldn't doubt that. This is just amazing. Had it occurred a month earlier, my suspicion is it would be more structurally integral further north just because the shear is not so strong. By the time you get to the end of October, you're already into the beginnings of the cold season, well into it. So the vertical shear in the environment at 30 degrees, 35 degrees, 40 degrees is in a different category than it was in July, August, and early September. So even in the face of that, this thing has hung on. So it's just an amazing event. Michael said it would be a joke to sort of, I take his role today as a Halloween costume, which I would, if I could do that, I would. I mean, I have such respect for Michael and everything about his personality and his intelligence. But I will say this is a magnificent storm.
Can we get this recorded? It is recorded.
It's recorded.
Okay.
It's recorded. This is a magnificent storm, and all this kind of joking that we always do about extratropics versus tropics will be dispelled for the rest of the day. That is a fantastic event. There's one in the long-term forecast that's in the middle of November. South China Sea, maybe Philippine Sea, that gets down into the 920s. And I'll show you a little surprise. Perhaps Professor Morgan's going to extolled the virtues of extratropical development at the end of his discussion today along the
Only
lines
fair,
of that
it's only
storm.
fair.
What?
It's only fair.
Yeah, it's only fair. It's only fair. So there's some real surprises here. Now, they're in Morganland at 384 hours in the forecast, but nonetheless, I've never seen this before in 40 years of looking at weather maps, ever. So it's unbelievable what's about to come. In between then and now, I apologize, I had to teach a class today in an emergency setting. I don't have as much to say as I would have liked to have said, but I'll get going on the rest of the discussion now. So Pete, if we can take a look at the satellite over the continental US for the last several hours, we'll see, you can still see the remnants of the circulation with Melissa. And here we are, this is the mouth of the Labrador Sea, so it's just got to get past Newfoundland. And if it does so, it's going to make it to latitudes at this late in the year that I've never heard of. So pretty amazing. At the same time, a fairly well-developed extratropical cyclone in southern Quebec has affected the New England states. Probably have something to say about what goes on tonight in Toronto, although it ought to be on its way out, substantially anyway, by then. Over the central United States, disturbance over the Dakotas and western Minnesota, obviously cyclonically rotating in the clouds. In this, we'll take a look at what that's all about. And then at an oblique angle, the action in the mid-latitudes this week, with the exception of Melissa making it all the way up to the north, has been an almost incredible run of cyclone after cyclone in the Pacific Basin, one of which undergoes a period of extremely rapid development followed immediately by a period of unbelievably rapid decay. I want to show you that in the maps. I don't have any diagnosis of it yet. Perhaps it's worthy of some further investigation. I think you might agree with that.
John,
So, yeah.
Just a couple things I just want to add to this satellite image. One of the neat things you see, if you were looking at this and didn't really have the sort of pseudo colors on it as well, you might think you might be in late November or early December with the colder air moving out over the Gulf Stream.
No doubt.
So
And over the Gulf of
and over
Mexico.
Mexico, which is where I was
Yeah.
going to go.
Yeah.
Is that these sort of events, when you get northwesterly flow off the continent this time of year, really begin to shut down the Atlantic hurricane season, at least in nearby coastal waters, because you bring this dry continental colder air off the water, and that's off the continent over the Gulf of Mexico and the western Atlantic. That begins to cool off the upper levels of the ocean, and so the heat content gets rapidly removed over time. It can recover a little bit, but when you get persistent northwesterly or just offshore flow in those regions, it can really shut down the potential for significant tropical.
Yeah, and the frequency is the point that you made near the end. By the time you get deep into the cold season, I'd say 3 or 4 weeks from now, we're beginning to enter the deep part of the cold season. Then you have a periodicity of 5 to 7 days on these expulsions of cold air from Canada in varying degrees. There's no way that the ocean temperatures in the near shoreline can recover anymore. You're so right about that. So this thing, how it's doing this, what it's doing is a testimony to how strong a vortex structure really is and how much it resists decay. They are amazing structures. Okay, so that means there'll probably be no tropical event that will find its way toward Mar-a-Lago, and as Clint says in Unforgiven, deserves got nothing to do with it. So, okay, let's keep on going though. Let's take a look at the radar over the continental United States. Here's the precipitation echo already moving out of New England. That's kind of more rapid than I expected. This is not Melissa. This is part of the extratropical complex. We'll see on a larger scale the upper level maps. You can kind of see the distinction between the two. This is the extratropical development that had taken place over the last couple of days over the eastern part of North America, and particularly robustly over New England. And then you can see one of the several events that have come across the Pacific Basin, making an impact on the Olympic Peninsula and probably into the Puget Sound as the day wears on. Other than that, some lighter precipitation over Minnesota, the Dakotas, associated with what we're yet to see at upper levels is an upper disturbance that's made its way southward in northwesterly flow. Wintertime, this becomes the producer of maybe an inch or two of powdery snow, and then followed by temperatures in the single digits or below zero. Alberta Clipper type disturbance with an assist from a little bit more well-organized upper disturbance dragging it southward. So those are fun when they come in December, January, February. But largely across the continental U.S., pretty decent day. I think this is part of the synoptic development tide that we can see pieces of here across the Northeast, but there's also probably undoubtedly a lake rain component to this because the lake's pretty warm and this air on the northwesterly flow side of the cyclone is certainly colder and drier, and so there's going to be some enhancement at a minimum to the precipitation there. Which is often, we talk about it only when it comes in the form of snow, but there's lake effect rains as well. Okay, let's go to the super Pete's if we could, Pete. And let's start at 500 millibars. And this is from 7 o'clock this morning. And you can see a broad upper low over the eastern part of the United States and southeastern Canada, comprised of a couple of different short waves. One of those features is right off the Gulf of Maine at 12Z this morning. Fairly sharp, 90-degree wind shift from Albany to Portland. Almost no wind at the center of it. It's about a 5-knot zephyr at Albany. Maybe there's something wrong with the balloon, but if there isn't, that's not surprising either. It's light winds in the middle, very strong shear at its boundary. And you can see there's a pretty decent upper wave in there. A second one with colder temperatures over the south of Cincinnati, or sort of centered around Cincinnati and the Ohio River Valley. Pretty decent temperature contrast, but it kind of flattens out and relaxes to almost nothing all the way by the time you're into Tennessee. Here's a little, I think, warm bubble that is Melissa. And you can see Melissa has carved out a little upper trough at 500 millibars as well. So fairly distinct from the two little short waves embedded in the long wave trough over the eastern U.S., responsible for the development over parts of Canada, New York State, and now exiting Maine, as we saw on the radar. So that's quite a separate feature, and its path has been, of course, like this, right about there, affecting no land since it affected the Caribbean. Probably hit Bermuda. I don't know what happened at Hamilton.
Northwest of Bermuda.
Did we just missed Hamilton? So that's good for them. So a lot of destruction in the Caribbean, a little bit less as it's gone further north. Here's an upper disturbance that's carved itself out pretty nicely, actually, in the flow over the Dakotas and Minnesota. About minus 28 or so is the coldest air in that thing, so not something to sneeze at, but not really bitterly cold yet either. And the wave is of substantial enough size that we could see an obvious swirl on the synoptic scale in that exact same region. Though probably not much developmental potential because the baroclinicity is fairly weak associated with that. And then finally over to the west coast, deep low in the Aleutian, southeast of the Aleutian chain in the Gulf of Alaska. This is the amalgamation of several disturbances that have kind of congealed as the week's gone on there. We had a great discussion both days, this week and Tuesday and Thursday, on the weather discussion. Yesterday's particularly paid attention to that. And Nikhil.
Yeah, I was just wondering, do you think there's like a significant enhancement of the downstream ridge by Melissa that's helping to enhance the trough over eastern U.S.?
So, yeah, the question is there substantial amount of convective activity, still substantial enough to be contributing to this ridge? I think it's certainly true that there's some contribution. There's been a historical contribution, I wouldn't doubt very much. Whether it continues to make a substantial contribution, that maybe it's just kind of splitting hairs on the words. And then, so I don't know the answer to that. I think the precipitation shield and cloud shield associated with Melissa is a little bit more impressive, surprisingly, than the one associated with this disturbance. So I'm not sure that there isn't maybe something close to an equal contribution going on there. Sometimes the phasing of these things is just not right. You know, if Melissa had no competition, perhaps it would kick up an even more extraordinary ridge. This thing here has maybe got a role to play in modifying that influence. I don't know. It's a really good question. So, don't know. And we'll see at 850, it looks a little bit more intriguing, this structure. And then at 500 millibars on the west coast, deep low, which, as I said, is an amalgamation of disturbances that have occurred over the week. This one, though, on its southern periphery has a really sharp baroclinic zone. This is 20 degrees C in this small range, from temperatures as low as minus 30, because it's minus 37 deep in the cold air just south of the western islands in the Aleutian chain. So we'll see that in the satellite picture, deep, well-spaced convective activity. And then this broad baroclinic zone, which is a shear line as well, as we'll see. So let's go to 300, Pete, if we could. And look at this jet that we have. Earlier this week, there were moments where the jet was in the 200 knot range, 100 meter per second range. Here it's at 174, exactly where you might expect it would be, sitting on top of the 500 millibar baroclinicity. Here's the deep upper trough to its north that is really the Aleutian low right now. And then sharply curved flow between the jet to the south. Melissa's right about here. It's about the warmest temperature. And then the anticyclonically curved flow up over Quebec. So the maximum upper divergence is just about where the cyclone center was over this northeast storm. Look at this wind at Portland, 115 knots. Isolated well over 100 knots right there, so really peak wind, well observed at exactly the right time. And then if we go to 850, Pete, you can see Melissa in association with this East Coast storm in a little bit more detail. So isn't this interesting? Here's the deep disturbance that's developed in the lower troposphere associated with the sharp S-shaped curvature, cyclonic to the south and anticyclonic to the north, big divergence right on top of that. And there's Melissa. And this H in red indicates it's a local warm spot. So it still maintains at 7 a.m. today at this latitude, which is about 39 degrees, 42 degrees, or something like, 39 degrees. It still has a warm core. It's not so obvious, but it's analyzed as such, and it certainly has a strong circulation in the lower troposphere. But so does this beast out to the northwest. Look at that circulation, just extraordinarily large scale and very intense. These are every 30 meters, these geopotential height contours. So this wind here, sort of channeled perhaps by the Queen Charlotte's and the rest of the BC coast, but that's 80 knots at 850 millibars. It's howling through the channel there on the British Columbia coast, and it's 50 knots right, I think that's in Nanaimo on the coast, just north of Vancouver Island. So very, very strong winds associated with a really intense disturbance. The baroclinicity even extends down to 850. Here it's 10 degrees over this distance. So that's a deep frontal structure that goes back into the upper troposphere. And then finally, here's the 850 manifestation of the circulation we saw in the satellite movie. Quite sharp circulatory winds evident here, strong winds in the 30 to 40 knot range in the Dakotas, and then 15 at Green Bay, and then I like this easterly at International Falls at 20, so the circulation center is right around in there, just about where the temperature is lowest, -4. There might be a -5 that's unreported because we don't have the funds to send up radiosondes everywhere, even though that's not a regular site. I'll take that back, but it would be nice to have one there today. Okay, can we, Pete, go to the Pacific satellite image? Beast number 1. Actually, it's beast number 4 for this week. This would be a great week to look at the whole animation of a week, but no time, and I didn't have anything prepared to say about it, unfortunately. One thing you can see very obviously in this satellite picture is, number one, enormous cloud shield associated with the last of these disturbances that's kind of made its way onto the coast and then through British Columbia and Alberta and Saskatchewan. So the big dividing line between open cellular convection over a broad swath of the North Pacific and none is probably that baroclinic zone in the lower troposphere. It was about here at 500, at 850 it's down further south. So this is where all the cold air spilling out off the high latitude Arctic has kind of come in. Some of these patches of convection get a little bit more organized than others. So this one right here is an example. It doesn't start to have a swirl to it, so there's no cyclonic organization, but there's kind of an amalgamation of convection. Brian Mapes talked about gregarious tropical convection. I think sometimes there's gregarious extratropical convection in these cold pools that come out over the Pacific Basin. And then they get a little bit more intense, indicated by the colder cloud tops just south of the Aleutians, but they don't seem to have the organizational potential that this one does. So anyway, that's interesting. Again, ITCZ has some big gaps in it this week, like we've seen a number of times, although much better filled in this week south of Hawaii than we've seen in the last several weeks. So that's interesting. But unfortunately, this only shows one of the several disturbances. So what I'd like to do is go to Alicia's maps and take a look at a survey across the Pacific Basin from this week. And let's see, I think we'll go all the way backward in time, Pete, if we can. We don't want to be anywhere near today yet. Probably all the way to Monday. Yeah, one more, maybe one or two more clicks. Okay, so here we are at 0Z Monday, beginning of the week. Really wavy flow across the Pacific Basin, and this is 250 millibar isotax shaded in. This is a version of an extended jet, because we have a nearly continuous jet stream all the way from the Sea of Japan to northern Nevada. Okay, so it's got some waves in it, and a couple of places where the wind speeds drop below the threshold of 70-ish knots, or 70 meters per second. But nonetheless, it's pretty continuous. And at a relatively high latitude. The state of Hawaii is down here, so the tropics, subtropics are right there. So this is clearly a sort of a mid-latitude displacement for the jet, or a little bit further north than many of the longitude lines than it often is. That's especially true at the western edge of the Aleutian chain. So here's a little cyclone that even a couple of times before, if we could click back a couple of times, that would be nice. Look at this. There's nothing really there. 1,012 millibars, kind of zonally stretched out disturbance. Here's the thickness gradient in red and blue. It's in the correct location for the jet. It's in the right entrance region. So that's a place where you tend to have ascent, forcing for ascent. It's also down shear of a region of cyclonic curvature, and so there's probably cyclonic vorticity advection by the thermal wind, all of it happening at the same place. But it takes a long time for that thing to start to develop. So let's click forward every 6 hours. Not much development. 1,012 is still the sea level pressure, same then. Same, maybe 1,008 peaks out. Now it starts to contort, the structure contorts a little bit, and so one begins to see perhaps a little bit of a thermal ridge developing here, and that's significant because it signifies, I think, that you have a long isotrope Q vector convergence, which is largely controlled by PVA by the thermal wind, well, not entirely. And so, but at this stage, it probably is entirely. So this is now an indication that the dynamics of this upper wave that are kind of hinted at by the thickness field are really starting to take over for the development of this thing. And not surprisingly, we're down to 1,008. Let's go back a little, go forward a little more. 1,008 still the lowest pressure. Now it's below 1,004, and you can see much more distortion in the wave pattern, and we're down shear of a trough axis. So it's just where you want to be. And look at the anticyclone growing to its west. So here we go again. Then a little more distortion, tighter baroclinicity as indicated by the thickness contrast. Keep going.
And also the fronts are showing up really well.
Yeah, they sure are. You can start to see a pressure trough right at the boundary of the warm edge of this thickness contrast, and a pressure trough here at the boundary of that one. So nice warm and cold front. Go ahead, Pete. Extreme development. Still nice warm and cold front. No indication of the occluded type thermal ridge. One more time maybe. And then you see a little bit of a thermal ridge here, but really strong warm front, strong cold front. Sea level pressure is now down into the 980s. One more time. Then it's down to the 970s. Approaching the British Columbia coast. Keep going. This is now, let me try and count this out for you. 1,000, 1, 2, 3, 4, 5, 6, 7, 8. So that's 32, 968 or something just off of Queen Charlotte Islands. One more click. Maybe 970. What happened to it? So this is, go back 2 clicks, Pete. This is 0Z29 of October. 968 millibar low, just off the coast of Canada. 2 clicks ahead is 12 hours later. There's nothing left of it. That's the fastest decay I've ever seen of one of those storms. And we did actually a study of these, climatological study of these in the early 2000s. So I've never seen one like that. We kind of maintained our study over the ocean, so we didn't have the effect of the topography, which is substantial. There's no doubt running into the teeth of the Canadian Rockies or the Canadian Coast Range is going to have an impact on the intensity of a well-developed cyclone. But it's not the only thing. Underlying this, and without time to explain more, and this would have to just be a research topic, underlying it, you can see how the thickness field, we go back 2 times, Pete? See how the thickness field loses a lot of its integrity. Up to this point, it has sort of a nice frontal structure, very clear upper trough right there, upstream of the cyclone center. Watch what happens to this curvature in the thickness field. I don't even see it left anymore. A little bit down here over Washington State, but that's well divorced latitudinally from the cyclone center. The whole upper level structure just dissipates almost immediately. And what I think is probably going on without clear explanation of the details is that when you go back 2 times, Pete, we've got an intense cyclone off the coast. And there's a huge amount of frictional convergence, even over the ocean for that. And so you're piling up mass in the middle of that storm. So long as you have an upper level divergence valve, an escape valve for that mass, well, you can keep the pressure low at the ground. If that escape valve disappears rapidly, so does your cyclone at the surface because it just can't maintain a low pressure in the face of a lot of mass converging at the ground, but no place to put it aloft. And I think that's probably what's going on. The mountains have a role to play in the cessation of that upper divergence, but they're not the only thing that does it. So that's kind of interesting. That's a great storm to look at in more detail. I didn't have time to do it today. But it's the first of 4. Here's number 2. Here's number 3 on the Aleutians, and number 4 is going to develop right here in an odd spot. This is a 100 meter per second jet right here in gray, okay, roaring across the Pacific with a development to its north off the Kamchatka Peninsula and one that's trying to get together to the south. So let's just page through here, and then it'll be the last things that I say. Storm 1 goes away. Storm 2 turns into, amalgamates with Storm 1, pretty deep Aleutian low over Kodiak Island. Look at that. Go back 2 times, Pete. Where did this thing come from? Go a couple more times. It comes from here. There's a development to the east. Watch this. It's going to start to develop further and further to the south, and then it explodes. That one will get amalgamated up here as well. Let's keep on going. So that's nearly the current time, right? Yeah, so this is the broad circulation that we saw in the lower troposphere at the beginning of the discussion. So intense baroclinicity all the way from 140 degrees west, almost to the coast of Japan, 1,036 millibars at 30 degrees north, and just off of Japan. Deep, deep anticyclone, and we'll keep on going. What's going to happen down here? Little development starts, actually pretty impressive development starts off the coast of Japan, bursts into the Sea of Japan, that's down into the 970s, and then the anticyclone gets even stronger. This is 1,040 millibars at one time. And then it keeps on roaring, strong, locally intense warm advection, and that's the story. A couple of cyclones migrating across the jet. So a very active period in the Pacific. There was, earlier this week, a little forecasted disturbance that emerged out of the baroclinicity well to the south, just north of Hawaii, that kind of roared toward the Pacific northwest coast and turned into a really small-scale, intense little tropical-looking disturbance. It was not tropical then. It's no longer even in the forecast bands. But there's a whole bunch of stuff going on in the Pacific that is fascinating. Fortunately, it looks like we're going to enter a period of boring weather in a minute. Yeah.
Could we go back to I guess it was the first cyclone you focused on?
The one that decayed
The
so
one that decayed
rapidly?
rapidly.
Yeah.
And maybe go about 3 or 4, is that it? Yeah.
Yeah, that's the
Okay,
one.
So I was just curious if you had any comments on the asymmetry in the wind field that emerges. I think it's the next forecast or the next analysis time step in that. Look at that really
yeah,
strong
yeah.
west and that jet that forms. on the
Right in
west
there.
side. Yeah.
Yeah, so this might be the thing that Browning and colleagues in England talk about as the sting jet. So in the lower troposphere, the pressure gradient can get really, really strong just to the west of the cold front. And there's been all kinds of different theories about why that would be the case. Not many of them have to do with the pressure gradient force. They have to do with momentum transport in the vertical and all that. My idea has always been trying to think about that, but on the side, not as a person really contributing, is that there's an enormously strong couplet of vertical motion tied to this kind of a structure at this time. One piece of the couplet is strong ascent. That provides a cloud head. The other one that gets nearly as strong in certain environments is subsidence. So what if you have sort of unchecked subsidence that can raise the pressure on the backside of the storm? Meanwhile, you have slow migration to the lowest pressure moving to the north. You can really intensify the pressure gradient, not so much by deepening the low, but by intensifying the subsidence on the backside. So I don't know if that's what's going on here or not.
So does that require then really weak stratification?
Weak stratification is the key. That's exactly what I was going to say, is that here in this, under the right circumstances, there's no resistance to subsidence. And so then you can really pile up the air in that column and really create a big positive pressure rise, which might underlie the asymmetric nature of the pressure gradient force. So it's worth investigating. That could be the case. Tyler?
Yeah, just from looking at weather maps like this, it seems like that feature develops right at the peak, or right near the apex of the intensity of the storm, and like right afterwards it starts decaying. I wonder if it's like what you guys are talking about. Like very, very close.
Yeah, I wish that I had the omega field that goes along with this, the QG omega, because it's somewhat attributable to some processes that you can identify. I don't have that handy, but it does look like something changes in that dynamic, if that's what's going on. But there's a period where that might be the factor, and then the next period, and maybe that contributes to some of the decay of the upper wave. I don't know. I don't even know the upper wave decays in this case. I'm just suggesting it might.
Would it be related maybe to the dry conveyor belt?
What is the dry conveyor belt?
Where, I feel like I've heard of this as extratropical cyclones, especially over the Midwest, like where the dry air comes from some higher altitude.
Oh, the dry airstream they talk about in Europe. Possibly. Usually the dry airstream, though, is going to have a really nice upper frontal signature. So you'll see a really sharp thickness contrast, maybe concentrated on the northwest side of the disturbance, and then the dry air spills in as it's forced to subside in the development of an upper level jet front system. I don't see that structure here, so I don't know if that's the case or not. Yeah, the dry airstream is a big topic of research over in Europe for a variety of reasons. Okay, I wanted to show just one more thing on our maps, and it's underlined. It's on my screen. So we got to go back to this. I got to get you in Okay, this is just way into the future. Again, a little of me being Professor Michael Morgan. This is like a forecast for tomorrow in terms of Michael's perspective. For me, it's like a wish cast. Look at this, 956 millibar low south of Okinawa. So that's a tropical cyclone. There's Taiwan. This thing's a beast. Let's just page forward a few times, Pete. What happens to that thing? Okay, well, 959 as it rakes the west coast, the east coast of Japan, stays pretty intense. 959, 958, 943. What's going on here? It's north now of Hokkaido, but well to the east. And so it's going to start to be an extratropical disturbance. One more time. 921, what? Kamchatka Peninsula awaits. One more. 908 millibars. I've never seen an extratropical cyclone on any map, forecast or otherwise, 908 millibars. That's as low as it gets in this forecast. Now, it's 348 hours out, but it's mid-November. If that happens, that'll break the all-time, as far as I know, the all-time mid-latitude sea level pressure minimum record by 12 millibars, which is more than 1%, well more than 1%. That's a big victory. That's like winning a 100-yard dash by 0.2 of a second. Nobody does that at international level. Okay? That's amazing. 908 millibars. And let's look at, this is fun, significant waves. Significant wave height is 1/2 of the valley and ridge that you create in these waves, right? So this is dark red, 42 feet. So you've got 84 feet of your critical wave height or whatever that means. Then throw some rogue waves in there that'll double that size, 200 or so feet of heaving seas off the Kamchatka Peninsula. Okay? Unbelievable. I wonder if someone can see that from her back porch. You maybe be able to do that. So pretty unbelievable. I don't know whether or not it'll happen, but certainly it makes for interesting reading for the next couple of weeks. Will that thing really persist in the forecast? I'm going to stop there. And then I'll show the cold pool. We're now the 9th warmest ever. I think it's that one. I think it's this one, yeah. And then slide up the page. We're the 9th warmest ever, September 1 to October 30th. And we kind of got back to about the average and then had a period of stasis this week. So we're right about there. And then tomorrow's Halloween and then the 1st of November. So we have never really been close. We've been close to the average, I should say. We haven't made a consistent run in a long period of staying close to the average. So pretty interesting. We only have, for my liking, one more month to go. After that, I care about December 1 through February 28th as the winter season. So we'll see if we can keep going and staying well under the average and see where we end up for this year. I don't have high hopes that we'll break the record for September 1 to November 30th, but I don't know what's going to happen next. Nobody does. We'll see. So pretty unbelievable. Okay, thanks. And thank you, Pete, for driving through.
So I'm going to start, Pete. Yeah, thanks. I'll channel my inner John Martin. And actually I want to focus on that storm in the Pacific, first of all, since we are going to go into tomorrow in my world. Welcome to my world, John. Let's go to Pivotal. And it's up there yet or not? I'm going to just start a new one. And we'll go to models, we'll go to GFS, and we'll go to the 6C run. That's the one, right?
Yeah, 60
Right.
from the 30th, yeah.
There's just a couple things I wanted to point out on that. 6C from the 30th?
No,
from last night.
31st,
Yeah,
I'm sorry.
okay.
I was thinking today was
Right.
the 30th.
And we'll go to the view will be continental, and we'll go out here in the Pacific. North back. I think I got that right. North Pacific.
Yeah.
240. Okay. And let's just advance to, was it 384?
348.
No, 348. 348. Okay. Beast of a storm, right? Okay, so extratropical cyclones can be really interesting and exciting, as I often say. That's me being John. The reality is we know that this did form and initially had a tropical disturbance associated with it. But the thing I want to look at is are the look at the dynamical tropopause for this event. So let's scroll down to what they crudely call upper dynamics. I think that, yeah, theta, we'll look at theta first, or just focus on theta. So I've been getting more and more interested in kind of returning to sort of my roots in terms of the things that I've been interested in early in my career, particularly looking at the dynamical tropopause. Because again, this summarizes sort of the key dynamical information in the upper troposphere that you would otherwise have to get by looking at a series of potential vorticity maps from the mid-troposphere all the way up to the lower stratosphere. All the key dynamical information, it's believed, or I'll assert, is tied up in this particular map. Upper fronts show up as strong gradients along the dynamical tropopause. So this is potential temperature along the 2 PVU surface, and the colder temperatures along this, so you can see the thermal contrast, or at least the thickness contrast, or not thickness, the potential temperature contrast along this particular surface. These are winds interpolated to that surface. Now the surface can of course be multi-valued where you have folds, but I thought the evolution of this little swirl in the dynamical tropopause was just fascinating. It's one of the stronger ones that I've seen that cuts all the way in, not just from these higher temperatures that are in the 360 or so range, all the way down to temperatures that are, close to lower to mid-troposphere. So if we could step back a few clicks, Pete, please. Let's look at the evolution of that. I think that's pretty, really awesome to see the development in the mid-latitudes of this particular event. We can also just step with the arrows to it.
It's not an animation, but, oh, yeah.
So we can go back a couple more. One of the things I was looking for, we could start right there. Since we know this had origins in the tropics, would we see any evidence of that tropical, remnants of the tropical cyclone along this dynamical tropopause? And it doesn't really show up well in this. But looking at this sort of area where you see the difluent flow emerge along the dynamical tropopause, as you have, at least at upper levels, the subtropical air along the dynamical tropopause is on top of. So it's like you have two different, my hand is the dynamical tropopause in the lower mid-troposphere. You have sort of this wall here. We could do a cross-section through this, where this is a little bit higher above it. But watch what happens as time emerges. You've already seen sort of the punchline here. We'll go forward in time. You'll just watch as the cyclone begins to develop. This begins to, again, this difluent region increase, and eventually you carve out this area where there's extreme warmth. And that's probably associated with significant latent heat release, I think, in the upper troposphere. The only way you're going to increase the potential temperature along the dynamic tropopause, d theta dt is not, theta is not conserved if d theta dt isn't. And although we're looking at a Eulerian perspective here, this is very likely due to some diabatic heating that's occurred in the lower troposphere beneath the tropopause. It's just warming this up. It doesn't quite get as warm as this sort of subtropical tropopause here, but it's getting warm. We go another click, please, Pete, and just watch as this kind of races forward. And it's forming another jet, again, and tropopause, really strong tropopause gradient through here, and that's going to be associated with a jet. But just look at that wrap up. That's just, again, a really, really interesting thing. And maybe the stage gets set by already having this very strong jet to the south of the cyclone that helps it roll up in a cyclonic fashion. We talked about that years ago when we're thinking about sort of how does why does it roll up cyclonically as opposed to anticyclonically? It could be because it's in a presence of a very strong, I guess it's probably the subtropical jet just to its south. So a really interesting cyclone in the forecast, not too distant future, 350 some hours out. We'll see. We'll see if that happens.
That is amazing.
So I want to transition to a couple things. First of all, an apology. For those of you that were expecting a nice dry weekend last week, I said, oh yeah, dry. I showed you a picture of from our wharf run that suggested that a trough that was in southern Manitoba was going to pass by us. It's like, the model doesn't produce much in the way of precipitation. And frankly, in all fairness, the Weather Service only had 10 or 20% chance of showers. They didn't expect much to happen because the surface layer was so dry. Well, you know what happened on Saturday morning yesterday, and most of Saturday morning last week. It was kind of a damp, miserable day in the 40s until the precip ended, but it was just kind of cloudy all day. We expected the clouds. The precipitation was not expected. And I haven't done a deep analysis of that, but I believe the key thing was maybe the potency of the upper trough that passed by us was just strong enough to help moisten the column even beneath the that strong inversion that we saw. And so we were able to get some precipitation there. But that was sort of not expected. And we'll see, just as a sort of a hint, this will make John excited. I'm still channeling John here. There's a possibility, I think, tomorrow morning we'll have a very similar event, but it will be a bit colder, and we could actually see our first flakes of snow tomorrow, perhaps. It's an outside chance, but I don't think it's a zero. I don't think it's zero. Last weekend, I didn't think that anything was going to happen. This weekend, I'm going to go for maybe a flake. Okay, so let's go to that first link that I had, Pete. I'm going to go back to talk a little bit about Melissa and some of the what happened. This is a clip from one of the NOAA flights into Melissa back on the 27th. And we have volume here. There's a, is that coming through? Maybe not. But you can sort of see the violence of the travel on this during this flight. Camera person just kept it focused in one direction, but there was this was just an interesting flight to imagine to be on. Look at the drops on canisters here on the fallen. This is when you sort of stay in your seats and have your seat back tables and you're upright. I think that's probably starting over again on the loop. But there are probably better loops that you can find of this, but a really sort of rocky flight for folks. But a couple things there. Oh, there we go. Yes. Fasten your seatbelts. Nice. So, I don't want to stick on this too long, but a couple things I want to say. First of all, I mean, we have to really appreciate these folks that are going out there taking these observations. I mean, there was a time several months ago when the thought was we weren't going to have any resources to actually make these measurements that can help save lives in the Caribbean and other parts of the world, certainly over the continental U.S. We haven't had any strikes here this year in terms of hurricanes at landfall. But it's the work that these guys are doing. And just think about it, these are unpaid folks out there sort of risking their lives to get the key observations to help improve our forecast. So that's certainly something that's appreciated. I had an opportunity a couple times a couple years ago when I was at NOAA to fly on these. And I was like, well, I'm kind of busy. There'll be another opportunity. And, well, they just weren't. So that would have been kind of fun to be on, I think. Hopefully I'll keep my lunch or whatever I eat before I got on. Next thing I want to do is just show the impact of Melissa. We can get out of this. This is, and I haven't verified this, but these are supposedly NOAA from Syria, some photographs. This is before Melissa's landfall, and this is sort of standard lighting along the island of Jamaica. Kingston is here, Montego Bay here is over here. And if you recall, as John was showing in the loops that Pete had, the cyclone track was over the western part of the country. So this is a satellite image after the passage of Melissa, and you can get a nice sense, an unfortunate sense, of where the power outages had occurred during this, following the passage of Melissa. Again, the main area here around Kingston and Spanish Town and these areas here, not much in the, they still have their lights on, but really the western half of the island, with the exception of maybe some of these tourist areas along the north shore, Montego Bay, Ocherias, have some lights, but interior it's just dark. So unfortunate for them. I saw an article, I didn't get a chance to read it, but apparently Jamaica has a contingency fund that they have, I guess, for these sorts of disasters, and they may be well positioned because of their sort of forward thinking to recover quickly from this, which would be a really positive thing, and it shows the benefits of having a good civil society and government that's in place to help folks when disasters like this occur. So we'll see what happens, but that's one thing to mention about landfalling tropical cyclones, some of the impacts, and you can see those from satellites. The next thing I wanted to point out was an interesting study that came out in October of last year that suggests that, Weather Service, NOAA, the typical idea is that on average there are about 24 deaths, I think this is in the U.S., from tropical cyclones each year. The belief now is that, at least from the study that was done last year, came out last year, is that there might actually be hundreds of times more deaths than are actually reported, but this occurs over a period of time from after landfall as far out as 15 years. They actually, done these scientists that did the study did a careful analysis of tracking people in areas and looking for sort of this unfortunate term, excess deaths, based on some sort of baseline. And it's due to infrastructure being destroyed, people having to move around, stresses of people not seeing their regular doctors, not being able to see their regular doctors, facilities being closed, communities being disrupted. But they tracked folks around, and they really think the number of deaths could be in the thousands. And this is happening not just in the immediate aftermath of a landfalling hurricane, it could be really in the decade that follows that, which is kind of an interesting social science thing, but it also suggests what do we have to think about when we have these landfalling cyclones or any sort of so-called natural disaster in terms of how the public, how we respond to it and how we make sure the resources are available for people to recover. But if you sort of do a search, you can find this story. This is an NPR story. We're not going to play it, but you can find a lot of links to this report, which I think are really interesting. Okay, thanks, Pete. And then we'll next go to NHC, and then we'll go to SIMS just to say a couple of things. Let's go to NHC first, and then we'll do SIMS. So here's Melissa. If we click on that, we can get some of the numbers. Scroll up just a bit. Let's just go to the public advisory, I guess. Got the latest numbers on it. So this is now post-tropical cyclone Melissa. Winds in the last report were at 85 miles per hour. Pressure has come up to 973. It did get down to about 892 or 893 just before it made landfall on earlier this week. And the track of it, we'll go back to look at the graphics and see the forecast track. You can just click on, yeah, that works. Okay, so the region of tropical storm force winds is this sort of yellow or mustard color, and then the brown is the hurricane force winds. And again, it's expected to track to the northeast, just missing sort of the eastern parts of maritime Canada, and then end up southeast of Iceland with storm force winds as it moves into the far North Atlantic. But other than some rain and wind along coastal parts of Canada, this is going to be largely out to sea until it moves into, I guess, the eastern parts of the Atlantic. And really, it looks like the Atlantic hurricane season is quieting down, at least for the next few weeks. We'll just see what happens next. When I was talking about those cold surges of air, cold, dry air moving off the continent, I didn't want to say, we're done, but it just makes it harder to get a very deep, intense cyclone. Like Melissa, if you don't have deep oceans, the sea not having large heat content as we move later into the season. All right, next I'm going to go to SIMS. And we said that was what, 970, I forgot the number. If we click on this for just one sec.
Yeah, 972.
972, is it there? It doesn't show it there, does it? It's in the 970s, Okay, so let's go to SIMS. This is kind of a neat thing. If we click on Melissa, and if I go to the MPI as an example, this is really, this shows sort of broadly the temperatures here. The maximum intensity of a storm in this region.
I think this is mean sea level pressure.
This means a little pressure. Yeah, so mean sea level pressure, is in the just below 1,000 or so. So this isn't actually, this is just if you were assuming this was a purely tropical cyclone, it's now begun to take some extratropical interactions, and it's probably why it's gotten a boost in its intensity for this moment. And then for the maximum winds, if we click on the winds here, again, just 50, if it were purely a tropical cyclone. So this tool isn't really one that's appropriate for transition cyclones, but it gives you a sense. And if we could look at this map a little bit earlier in the week, you could sort of see and follow the progression of the cyclone. You can see it sort of steadily decreasing as it moves over colder and colder waters. So that's just a neat thing I wanted to show from that. Next, let's go to Kai, and we'll just do a couple maps there. That site is having some problems beyond just the dew point. So I won't, there it is, you just passed it, Pete. Thanks. And let's go down to the time height section, please. So here's our time height section for the next 60 hours. Again, it's always good to see that the forecast does go out 60 hours, so we can at least forecast that far, although we know we can go to 384 if we want. isotropes in yellow, the dynamical tropopause in green. We're seeing more and more of it as we move later into the season. And what's different between this and what happened last weekend, a couple of things. We had an upper trough that passed by. You can see the isotropes sort of bowing upward. Vertical motions are not particularly strong in this. These dashed lines indicate subsidence. Here's a little area of rather strong ascent by around 12 Z tomorrow. And then in red is the relative humidity. And last weekend, if you recall, or last Friday when we were looking at this, we had an area of moisture that was in the mid-troposphere, above 700 millibars to about 450 or so. This coming weekend, it looks like this is all most closer to the surface, so we are going to moisten up. Again, this doesn't predict a 100% relative humidity saturation occurring, but the fact that if this does verify and we do get into a column moistens up, we have this upper trough going by, we have a cyclonic circulation, broad cyclonic circulation above us. That's going to be associated with convergence at the surface, so-called Ekman pumping, and some modest descent. We could see, possibly, if it's cold enough, maybe a few flakes of frozen precipitation. Well, I guess if it's frozen, it's going to be flakes, right? Or it could be ice pellets, but I'm not going to predict precip type to that level. Let's look at the temperature forecast in the meteorograms. Again, ignore the dew point, that's wrong. But there's just a little bit of precip. Last weekend it was just bone dry. We actually do have a possibility of some light precipitation between noon and, between 6 a.m. and noon tomorrow.
Looks like less than a foot though in that case.
Definitely less than a foot. I would not bet on more than that for snowfall. Okay, let's go back to Pivotal, please, and we'll go to the GFS. These maps are non-functional today, largely. And we'll bring our view back to the US, please. 910. Yeah, so national, and then, yeah, there we go. Ooh, I didn't see that. Let's not look at that yet. Let's not look at that. I wouldn't believe it anyway. It's too far out. Okay, so here's the forecast for 6 hours from the forecast around 18Z today. You can see this trough in the thickness field. You can even see some light precipitation. That's the one thing I did want to look at, was a surface map to see if how much of that precip you saw over parts of Minnesota and the Dakotas was frozen or not. Could we actually go back to your superheat surface?
Yeah,
SPS, as we always call it. Yeah, it looks like right here, at least at this point, there's light rain. These are little dots, right?
yeah, that's.
Yeah. Temperature dew point spread isn't that, it's
Everybody's got
close.
a dew point higher than 32.
You're right.
Western, South.
right. So just light rain showers.
That's a snow shower.
That's an ice pellet, yeah.
Oh, it is ice shower.
It's an ice pellet, yeah, I think that's a dot. Is that a dot? That would be light, just a rain shower then, right? So no frozen precipitation now, and so that will actually make me amend what I said earlier. Yeah, we could see some light rain tomorrow. I think flakes are probably
39 degrees.
out of the question. So going back to Pivotal, and let's just go forward in time. We can just step right here with this. These are every 3 hours initially. See this cold pool as it moves southward. If we stop for just a second, that storm on the east coast continues to sort of wrap up as it moves into out of Maine into southeastern Quebec. Again, really strong winds, windy period there with some rain and snow showers over parts of Quebec and Ontario. And over us, still dry, but mixed rain and snow is predicted in terms of precip type, by the methods that they use here to come up with a precipitation type. But nothing of significance. And on the far western part of the United States, continental United States, we see some more rain coming in to the Pacific Northwest. Let's keep clicking, please, Pete. Northwesterly winds, cold advection over us, and we're getting into tonight, and then tomorrow there is a nice trough axis that's here. Again, that's going to help support some convergence, and maybe that's probably the sole reason we're getting precip with clouds tomorrow, and I think it's just because this is 12Z. I don't think these are convective showers, or particularly strong convective showers. There is a possibility as this trough axis shifts by that we could see some precipitation, but the likelihood would be liquid. If we do a little, let's do a sounding here.
Yeah, I bet the stability's pretty low. We're underneath the cold dome.
Yeah, that's gonna certainly lower it. Best precipitation type, it says snow, I looked at this earlier, and maybe at this time,
So
that's close, but again, it just has to fall just up there, right? Up there, how far is up there? It's not that far, but we could probably get a, you know, if we were to see a flake, it's not gonna
It'll be
be,
intensity dependent with
Right.
those temperatures and dew points, and the intensity looks low, so I'm gonna say.
but how low do you need that freezing level to be before you would be?
32 would work for me. If we had 34 over 29, I'd be saying, yeah, we got a
Okay.
chance. 34 with 33, if that's right.
Yeah, right,
Too
right.
close- Too close to the fence.
Too close, all right. So John's, his heat miser today.
Yeah, I am.
I'm trying to-
It's a good way to say it, yeah.
Okay, and we can just click forward on time here, so we don't have to keep going back, and just see how that changes. Go 3 hours ahead,
A little worse.
35, 36, and scroll down a little bit. Yeah, they're now saying best guess is rain, so even that small, subtle change gives liquid precip. So let's get out of that. Trough is now passing us to the south. Let's continue advancing forward on this just a little bit. Again, fairly quiet weekend, but I think tomorrow, again, we saw the layer of high relative humidity, so clouds around us tomorrow, and also with just a broad, although weak cyclonic circulation, cloudy. But warm advection is beginning to start up again, certainly over the plains, and we can advance a little bit more rapidly. Let's go to 48 hours. And we can even just step in huge chunks now over time. And the weather across the country, like it's been most Fridays this semester, is relatively quiet. Go to 72 hours, please. Okay. We do get a brief warm-up on Sunday, and then we have another front that's about to pass through us. You can see the wind shift from southwesterly flow here to northwesterly flow, and a front. There is, if you were to do a cross-section through this, again, just because of time, I don't want to go long, there is some weak frontogenesis close to the surface, and that's where this precipitation begins to set up. We step ahead another day, front has gone through, and now we're beginning to rebound with warm advection starting back up again on Tuesday. Weak cyclone goes to our south on Wednesday, and so again, just a really quiet week. Let's go to 144, then at 168. Cyclone goes offshore. Look at that. We're warming up. Let's see how warm. Do a quick. We can either go temperatures or look at the sounding. Let's go temperatures. Let's do that. This is at 60, so this is at night. We're already 51, which is like 15 degrees warmer than we've been most times at that point in the night. Go into the day. Oh, we're in the 60 forecast. We didn't change this beat. I mean, everything we've said is still valid, but it's just, I want to make sure we get the timing right on this. So if we go back to the surface map for a second, Pete. And let's go back to 144. Okay, that's Thursday. So there's a warm-up that's expected. And let's go to 153. And remember, we've set our clocks back and all that. So if we look at the temperatures at this point, yeah, maybe getting to the 60s. I know John does not like high dew points. 55 or above you don't like, or 50.
Yeah.
So let's look at dew points.
We're safe.
We're good. Safe. All right. Let's go to 162. We have to wait for this to come through. So we creep up a little bit, go to 168. So next Friday, if this forecast were to hold, yeah, we get a little bit of surge of high dew points and then things begin to dry out. And then back to the surface map, please.
59 over
All right.
53.
So quiet week coming up. Back to cold advection, nice front. If we go a little bit further in time with this, a nice front sets up as it moves into the, going forward. That one's already passed out to sea, but later in the forecast, there's some nice examples of really well-developed fronts that show up at maybe this next cyclone. But time is short. So thank you, Pete. Thank you, John. Thank you, John, for coming to the, I won't call it the dark side, but coming to the appreciation for long-term forecasts, even if they are sort of fantasy land. But recognizing that tropical cyclones are important. Yes,
Something
Tyler.
I noticed earlier on, I don't know if it's 3, 4, 5 days out, it seemed like there's very zonal flow across southern Canada, where the front never quite
Got
made it
south,
to us,
right.
But it seemed like it was setting up a stronger baroclinic zone over southern Canada, where then now we have cold air available if you get a good cyclone to bring it down.
Mhm.
Now it's within shooting distance versus like over the pole or something.
Right, right. So, yeah, I mean, we have seen a migration over time of the main baroclinicity from central and southern Canada to just along the border. But, and I don't know if that's a sign of what the upcoming season's gonna be like. But you're right, the ability for cold air to come in and stay in longer is certainly increased because the baroclinicity's gotten further to the south. I know we've gone over, but I wanna go forecast for a second. This is something John will not like, so you may wanna avert your eyes, John. This is the Climate Prediction Center's outlook for the next 6 to 10 days above normal, the northeast being a little bit chilly, and then 8 to 14 days, more of the same.
Boy, the whole country's above normal.
Yep. And then if you look at precipitation, and that could be people's blood boiling over because they don't have access to certain things. And then, but dry. So
Wow.
not a very snowy period coming up. So maybe our best shot will be maybe tomorrow morning for just an hour. If you look out just the right time and use your imagination, you might see something. Have a great weekend. Thank you.
Thank you.